Those are your dimensions, and I'm going to give you a moment to look these over. So this is the section over here you want to look at. Now, I may have other things over here that you don't need for right now, but this is what you should have. And this one, that was 222 pi. Oop, not that guy. You could have also said, oh, you probably would have said about 7. So this one here, that was 222 pi. You might have said it was about 7. And then this one down here, that's 100 pi. What's going on? No. The calculator's not working right. Well, see, I knew that didn't sound right. Because you know how pi is 3.14? It's like it's not even paying attention to that 100. Let's try that again. Oh, there we go. That's better. Okay, so here's a 222 pi if you gave it to me as a decimal. And then that bottom one, that 100 pi, if you gave that one to me as a decimal, would be the 314.2. How'd you do with these three problems? Do you need me to explain? Do you need me to do one of them from start to finish? So, like this first one here, I gave you everything you needed to know because I gave you that slant height of the 4, so that went into the cursive L. And then the perimeter of the base is 2 plus 2 plus 2 plus 2, so that was the 8. Area of the base, it's length times width, so 2 times 2 is 4. This one should have been really simple because I gave you everything you needed to know for that problem. All you had to do is plug it in. Now, this problem here, I did not give you the slant height. I gave you the straight up and down height. So you had to do Pythagorean theorem right here to get the slant height. And this piece right here would be a 10. So that's why you see my work up here. 7 squared plus 10 squared is x squared. And I went ahead and I did that as a decimal. Did anybody do it in simplest radical form? Okay. So I got that slant height to be about 12.2. Now you'll notice I did the shorter version of the formula. Did anybody else try the shorter version of the formula? Or did you guys do the long one? Do you want to see me do it with the longer version? You want to see it with the longer version? Okay. So if I did it with the longer version, it would be the pi RL plus the pi r squared. Okay, so let's just go through it and see what we know and what we don't know. What's the radius of this cone? So I would put 10 into the r. And then the slant height, that's what I was talking about a second ago. I would have to stop and do Pythagorean theorem here to find this slant height right here. So it would be 7 squared plus 10 squared is x squared. And that came out to be 12.2. So that would be your slant height. Everybody okay with the Pythagorean theorem on this one? Why it's 7 squared plus 10 squared? Okay, so that made about 12.2. So that's going to go into the little lowercase cursive L. And then I'm going to recopy the plus pi. And then in the radius, I'm going to put the 10 and square it. And then I'm just going to work it out. So like on this one, if I took 12.2 times 10, that would make 122 pi. If I took 10 and squared it, that would make 100, so that'd be 100 pi. And then if I added those two together, that'd be 222 pi. And then I showed you a second ago, if you wanted to give me a decimal, that would be 697.4 if you go to the tenths. So I did it with the shorter formula, and you get the same answer. So I don't care how you do it. I just hadn't done the short one yet, so I wanted to show that to you. Okay, and then the bottom one. Hopefully everybody was okay with the sphere. Is everybody good with the sphere? Yes. Yeah, the sphere is the easiest shape ever. Even when we do volume, even though the volume formula is a little bit uglier, as long as we have the calculator, it's no big deal. Because some people are scared of fractions, but the calculator takes all that fear away. Okay, we okay with this? Okay, let's go over last night's assignment and see how you did with that. Just a second. Okay, so I'm going to show you 1 and 2, and then I'll show you some more after that. So I showed my 3 lines. So first line was for formula, second line was plugging in of the numbers, third line was for answer. And then if you you want to see me go over any of these here in a second, I'd be happy to go over whatever you want to see. But this is the kind of stuff I was looking from you. Yesterday's paper that you guys gave me that I handed back, that looked really good. I was really pleased with how people showed their work. So formula, plug in of numbers, answer.
Oh, there's one that said I didn't have the formula, which I'm pretty sure I did.
Number 3, I did it as a, well, this is what it came out to be to the nearest tenths. And then this right here was in simplest radical form. I didn't know if anybody would have put it like this, so I just did that just in case anybody used the 10 square root of 2 instead of the 14.1. Okay, so that's number 3. Okay, number 4. I kept this in simplest radical form, and then I plugged it all into the calculator and got about 250.1. Now, your answers could be slightly different depending on if you rounded this sooner in the problem or if you waited until the end. So if your answer is pretty close to this and it looks like you've plugged in pretty much the same stuff, then you should be okay. And like I said, I'll do whatever you want to see here in just a second. Okay. And if I'm going too fast, just ask me and I'll do the problem. Number 5. This one was just lateral surface area, so this was no big deal. Just pi r L. Plug in the radius, plug in the lateral height. And then I left my answer in terms of pi, but then I also gave you the decimal in case anybody did that. Okay, number 7 was total surface area. And I went ahead and I used the longer formula. So if anybody used the shorter formula on that, your work will look different, but answer should be the same. So 37.5 pi, or approximately 117.8. And then number 8. This was our sphere. Hopefully nobody missed the sphere. So it gave us the radius of 6. We didn't even have to have the diameter or anything. It gave us the radius of 6. We just plugged it into the formula and work it out. Okay, do you want to see me do any of those?
Number 4's answer again. I think that was
See number 4's answer again. Number 4 was the hardest problem of all of them.
Yeah, I got 262 on it.
Okay. We can look at number 4. Number 4 was the hardest problem that we had on the page. And I was hoping you'd kind of go back and look at the problem that was like it that we did yesterday in the notes if you got stuck. Okay, so I'm going to do a little work on this piece of paper right here and on my paper with the picture. This is number 4. This is the hexagonal pyramid. So because it's the pyramid and I want the total surface area, I'm going to use the 1/2 PL plus capital B. Okay, and then I said let's assume that these bases are regular shapes unless we're shown otherwise. So if all these sides are 6, what would the perimeter be? 36. Okay, so I can put 36 into the capital P. We good so far? Okay, my problem is I don't know the slant height and I don't know the area of the base. So I've got to work on both of those things. So I'm going to work on the area of the base to begin with. And so if I want to find the area of this base, that's when I'm going to do the 1/2 AP. Okay, I'm just going to redraw that hexagon and start working it right here. And I think most of you are getting pretty good with the 1/2 AP. How long was the side? 6. Okay, so the apothem goes from center of shape to middle of side, and then the radius goes from center of shape to vertex. And then how long is this piece right there? That's a 3. Okay, if I want to know what kind of triangle he is, this is when I take 360 and divide by the number of sides the shape has. How many sides does it have? 6. If I take 360 and divide by 6, that makes 60. So what's this angle right here? 30. So this one's a 30, this one's a 90, this one's a 60. What goes across from the 30? So that 3 right there is the x. What goes across from the 60? X square root of 3. If this is x square root of 3, just tell me now, what is it? 3 root 3. 3 square root of 3. I don't even care about the radius. Okay, I'm going to stop right there, and I'm going to go ahead and figure out the area of my hexagon. So I'm going to take 1/2 times the apothem, which we just found to be 3 square root of 3. And then just a second ago, you guys told me the perimeter. What's the perimeter of the hexagon? 36. Okay, I just want to keep it in simplest radical form for right now, but if you didn't do that, it's no big deal. So I'm going to take 36 times 3, which is 108, and then what's half of 108? 54. So 54 square root of 3 is the area of the hexagon. So if that's the area of the hexagon, that goes into capital B, because capital B wants the area of the base, and that's what we just found it to be. Okay, I'm going to go back to the picture that's on the actual homework assignment. And I'm going to draw in the slant height. This guy right here is the slant height. That's what I don't know. And then this guy right here, we talked about him yesterday. He has a special name. What's he called? It's the apothem. It goes from the center of the shape to a middle of a side. Does everybody see that? It goes from center of shape to middle of side. So this is the apothem. And what did we find the apothem to be just a second ago? The 3 square root of 3. So this guy right here is 3 square root of 3. So I'm going to do Pythagorean theorem to find the slant height. So I know this is a 7. So it's 7 squared plus 3 square root of 3 squared equals x squared. So 7 squared. That 3 square root of 3 squared, you're going to have to put that in parentheses in the calculator if you want it to calculate right. Okay, so here I go. I'm going to take 7 squared plus the 3 square root of 3 squared. Uh-oh. This is the older calculator. A lot of you out there don't have to put the extra set of parentheses. This is a calculator that has an older version around it, so I had to close parentheses around that 3, and then I had closed parentheses around everything that was inside there. And you get 76. What do you do once you get your 76? Square root it, and then that is 8.7, and that is our slant height right there. So once I know my slant height is 8.7, then I can come back to my paper, and I can put 8.7 right there into the lowercase cursive L, and if you work all that out, you should get 250.1. Does anybody want to see me put it in the calculator? Does anybody need to see me plug that in the calculator? You're good. Are you guys okay today? You sure? Okay, do you want to see any others? 4 was the most challenging one, but that doesn't mean you didn't struggle with any of the others. Are there any others that you want to see? You okay? You're good? You sure? All right, let's move on. We're going to do composite surface area. This is not going to be on your quiz tomorrow, but what I'm assigning you today, I'm not going to make do until Monday, so hopefully your quiz doesn't take you very long tomorrow. When you do take the quiz, I am looking for the 3 lines of work, the formula, the plugging in of numbers, and then the answer. And you may have other work that you have to have off to the side. But I am looking for the 3 lines of work on the quiz, and then whenever you're done with your quiz, you can work on the assignment that I give you today. So the assignment I give you today, it's not due until Monday. And so hopefully tomorrow it could be kind of relaxing. Take your quiz and then have the rest of class free. Okay, I'm not going to do quite all of these, but let's see what we can cover. Composite surface area is when you're going to see more than one shape. So like here, this, does anybody know the name for just this one shape? Like not splitting it into different shapes, but just this one shape. It is a pentagonal prism. Except for I'm not going to work with this as a pentagonal prism, and I have a couple reasons why. So up here, we actually have a real life situation with this. It says the surface of a greenhouse is covered with plastic or grass. So we're assuming this is a greenhouse, and we're going to cover it with either plastic or glass. And then it says, find the amount of plastic needed to cover the greenhouse shown. If this was your greenhouse and you were covering it with plastic or grass, would you cover every single surface with plastic or glass? Most of it. What wouldn't you cover?
The door.
Okay. But your door would be made of something, though.
The bottom.
So the what?
The bottom.
You wouldn't cover the bottom of it. This rectangle down here, you wouldn't cover the bottom of it. Is that what you guys said over there? I knew you were saying something to me. I just was focusing on what Jake was saying about the door. So you would not cover the bottom of it. And then if you think about this as 2 shapes on top of each other, I'm going to see if I can put this under here. So the top shape is a what? If you just think of this as a top shape, I'm going to do this little line there and this little line here. What would you say that this top shape is? A triangular prism. And what about the bottom shape? A rectangular prism. Except for when you go to do the triangular prism, would you find every single surface of it? Which one wouldn't you find? You wouldn't find the bottom of it because you wouldn't cover that with anything because you're not actually going to have this covered in plastic or glass because then you'd have like a roof before another roof. Does that make sense to you? So if you had this shape right here, you would not put anything right here. Does that make sense? And then you're not going to put anything on the bottom because that's going to be on the ground. Does that make sense?
So it's just the outside except the bottom.
Okay, so we're not going to put anything on the bottom of this one, and we're not going to put anything on the bottom of this one. But I'm actually going to do this a little bit different than you guys might think. I am going to find the area of this triangle. I'm going to find the area of this triangle first, and then we're going to go from there. So what's your formulas for area of a triangle? Base times height, and I'm going to find two triangles. So my formula is base times height divided by 2, and because I'm finding two triangles, I'm going to multiply that by 2. So I'm going to kind of split this up into different shapes, and then after that will be a little bit more kind of like what we've been doing the last few days. Okay, so this is my triangle right here. I'm going to take this triangle and I'm going to blow it up. I'm going to put it up here so we can see it a little bit better. Can you tell me what this piece is right here? 10. That's this 10 right here, so this piece is the 10. And then, do you know what this piece of the triangle is? 12. This right here is 12, and that's because this piece down here is a 12, so that means that this is a 12. Okay, and so I need to find the height of this. So I'm going to drop it down, and that's going to cut this into a what?
6.
A 6. Without doing any work, do you know the height of this?
8.
It's 8. This is a 6, 8, 10 triangle. If you didn't know that, you'd have to stop and do Pythagorean theorem. 6 squared plus x squared is 10 squared. Does anybody need to see me do Pythagorean theorem, or are we okay with that? Okay, so right now I know the base of my triangle is 12, and I know the height of my triangle is 8, and so I have everything I need to know, so I'm going to just plug those in. So I'm going to go 2, and then the base is a what again? The base of the triangle is 12, okay, and then the height of the triangle is 8, and then I'm going to go ahead and divide by 2. Do you know these 2's right here? I can cancel them out. Does that make sense to everybody? Okay, so I'm going to cancel those 2's out, and all I'm left with is 12 times 8, and how much is that? Okay, so far I have found the area of these two triangles, and I'm definitely going to cover those with plastic or glass. Okay, now I'm going to find the area of this rectangle, and I'm going to find the area of this rectangle. Well, it may be too much, but that's what it is, so I'm sorry. So right now, with the top shape, if I find the area of this rectangle and the area of that rectangle in the back, is that everything I need to find the area of for the top piece? Because you said we weren't going to do this rectangle right here, right? Okay, so let's find the area of these two rectangles. What's your formula for finding area of a rectangle? Length times width, and because I've got two rectangles, I'm going to do 2 times my length times my width. And let's look at the rectangle. How long is it this way? 25. How long is it this way? 10. Let's look at the other rectangle, this one back here. Is it 25 this way? And is it 10 this way still? Okay, so both of my rectangles are 25 by 10. And we need to take 2 times 25 times 10. Can anybody tell me what that is?
500.
500. Okay, so that's my top so far. Now I have to work on the bottom. So my bottom is this rectangular prism, and what am I not going to find the area of? I'm not going to find this top one, this top base, and I'm not going to find the bottom base. Does that make sense? So what do you call that? If you're going to find the area of all of this, except you're not going to find the top base and the bottom base. That has a name. It's the lateral surface area. Is everybody okay with that? Okay, so if I'm finding the area of all the sides but not the bases, that's lateral surface area. So if I want to do the lateral surface area of our prism, I'm just going to do pH, because I don't want to add in the two bases, so I'm just going to use this formula right here, pH, and that's going to give me this rectangular prism's area, but it won't be the top and it won't be the bottom because I'm not including the bases. Okay, so for the bottom, I'm going to do the lateral area of the rectangular prism, and we just saw that the formula was pH. Now, which one do we have to call the base? Because it's important. The 8 by 12 or the 12 by 25?
8 by 12.
Which pieces am I not finding the area of? I'm not finding the area of the bottom one and the top one, right? So if I'm not going to include those, two bases, then those need to be the bases I'm working with. If I just want to find the lateral surface area, the area of all the sides, I'm not going to include the two bases, then I have to call this one down here the base, because I'm not going to find the area of him because he's on the ground. You wouldn't put plastic or glass on that. And I'm not going to find the area of this one because that would be a roof before another roof. Okay, so this has to be our base. So perimeter of the base, 12 plus 25 plus 12 plus 25, 74. And then how tall is that prism?
8.
8. Okay, and then does anybody have 74 times 8?
92.
Okay, now that I have all these, what am I going to do? Add them all up. I'm going to add my 96, I'm going to add my 592, and I'm going to add my 500. So I'm just going to draw an arrow to all of these and just say add. Okay, if somebody could kindly add all those together for me.
1,188.
Okay, 1,188, and this is feet squared. That would be my total surface area of everything for the greenhouse that I would cover with plastic or glass. This one, we didn't use a ton of formulas for like the shapes we've been working with. We kind of broke it into pieces. So I had to find the area of everything I would cover with plastic or glass. So does it make sense what I found the area of? So I didn't find the area of this bottom base because that's what's going to be on the ground. I didn't find the area of this top base because that's what's going to be on the ground. The ground. That would be the roof before the roof. And so that's why I did just lateral surface area and didn't include those bases. And then for the top guy, I just worked it in pieces, the two triangles and then the rectangles that were slanted for your roof. Okay, let's go to 3. I think this one will be easier for you. So we're not doing real life anything. You want to cover every surface that there is that you would see. So what do you think kind of shapes you have going on here? And what about the cylinder? It's half of it. So we're going to find the surface area of half of a cylinder, and then we're going to add that to what? The surface area of the rectangular prism. Now, let's talk about that rectangular prism for a second. Would you see every single surface? Would you be able to cover every single surface of the rectangular prism? Which surface wouldn't you be able to cover? You wouldn't be able to cover this top rectangle right here. Does everybody agree with that? Okay, so I'm going to say with one base. This rectangular prism will have the bottom base that we can work with, but it's not going to have the top base. You can't cover that. If you were to paint all of this, all of the surfaces that you could see, pretend this was some toy or something, and you were going to cover everything with paint, you would cover the bottom of it, and you'd be able to cover everything, but you wouldn't be able to cover this rectangle right here. Is everybody okay with that? Okay, so now I have formulas I can work with. So let's go to the surface area of a cylinder and find that formula. So total surface area, we have a choice. We can either use this longer formula or we can use the shorter one. You want to try to do the shorter one for something different? Now, if it's half of a cylinder, what will I need to do? Divide by 2. So I'm going to divide this by 2. So I'm going to write down the 2 pi r and then h plus r in parentheses divided by 2. Okay, now let's talk about the rectangular prism, but the rectangular prism is only going to have one base. So let me look at my rectangular prism formula. This is my total surface area formula for a rectangular prism, but if I only have one base, do you know what adjustment I'd have to make with the formula? It'd just be plus b. Instead of plus 2b, instead of the two bases, it's just going to have one base, so it would just be ph plus b. Okay? So it's going to be just pH plus B. Instead of 2B, it's just got one base because I can't find this surface area right here because I wouldn't be able to paint that because the shape's on top of the other one. Okay, here we go with the cylinder. I'm going to recopy the 2 and the pi. Do you guys know what the radius of the cylinder is?
Isn't 2?
No, it's 6 all the way from here to here. So all the way from here to here would be a 6. So the radius would be 3. So the radius is 3. And then if you were to set this cylinder up on its circular bottom, how tall would it be? This 15 right here, that's how tall he would be if you set him up. Okay, and then plus the radius again, 3. And then this is all over 2 because it's half of a cylinder. Okay, let's just try to work this piece out. So let's go over here. What's 15 plus 3? 18. I need to take the 18 times the 3. 54. Do you agree that these are going to cancel out? So 18 times 3 is 54, so I've got 54 pi. There's my half cylinder. Now I just need to work on the rectangular prism. So the rectangular prism is everything except this top base right here, which means we have to call this guy down here the base. If I'm not going to count the top base, then this one down here has to be the bottom base. Okay, so when I go to do perimeter of the base, what would the perimeter of this base be? What is it? 42. And then how tall would this stand? If it's sitting on its base right now, how tall is it? It's this 4 right here. Okay, and then capital B is the area of the base. And what would the area of this base be? 6 times 15? 90. Okay, we can work that out real quick. So somebody take 42 times 4 and add 90 to it. 258. Okay, let's just go ahead and put this in and get a decimal. If you kept it in terms of pi, this would be the answer. But let's just put all of that in, and let's do a decimal. What is it? 0.6. Good. 427.6, and this would be inches squared, and this would be your total surface area for everything that you'd be able to paint. So everybody understands you couldn't paint this top rectangle right here? Everybody understands that? If I had these two shapes to put on top of each other, I would do that. Okay, I want to try to do one more with you. Did you like that one better than the first one?
No.
Oh, well, that's a pity. I appreciate your honesty, though. Now, this guy, I can demonstrate. Here he is. If you were to paint this shape, let me make it smaller. We've got a what sitting on top of a what? This is not a sphere. We have a...
I mean a pyramid on top of a prism.
Okay, and we could be a little more specific. Do you notice how...
Pyramid on top of a cube.
Okay, we have a square pyramid on top of a cube. If you were to paint this, are there surfaces you wouldn't be able to paint?
Yeah.
What couldn't you paint?
The top face of the square and the bottom, or the base of the pyramid.
Okay, so I wouldn't be able to paint the base of the pyramid, right? And I wouldn't be able to paint the top of the cube? Does everybody understand that? So I'd be able to paint every other single surface that's here, but I wouldn't be able to paint the bottom of the pyramid because it's on top of the cube, and I wouldn't be able to paint the top of the cube because the pyramid's on top of it. Everybody okay with that? Okay, so let's talk about what we can do. So I can find, make this a little bit bigger again. I can find the surface area of the pyramid. But if it doesn't have this base that I can paint, then it has no base at all. Remember how a pyramid has only one base? So if I can't paint this one because it's sitting on top of the cube, then the pyramid won't have a base at all. Okay, then I'm going to find the surface area of the cube. And what could you tell me about the cube? It's only got one base. It would have the bottom base that you could paint, but you're not going to be able to paint that top base because the pyramid is sitting on top of it. So it's only got one base. Okay, let's look at our formulas, and let's see how we're going to have to adjust them. So the pyramid formula first. Our pyramid formula, this is the total surface area, but if it doesn't have a base, what would I knock off?
The plus B.
The plus B. So it'd just be the lateral, 1/2 PL. Okay, so this is going to be 1/2 PL. And then let's talk about the surface area of the cube, but it's only got one base because you're not going to be able to paint this top one here. So, yes, it'll be PH plus B. Instead of 2B, it's just going to be 1B. So PH plus B. Okay, let's look at the pyramid. So I've got 1/2, and then the perimeter of the base. So this is 12, this is 12. What would the perimeter of this base be right here? 48, 12 plus 12 plus 12 plus 12, so that'd be a 48. Okay, my problem is I don't know the slant height. This guy right here, he is not the slant height. You may think he's a slant height, but he's not. This right here is the slant height. That's what I need to figure out. But I do know that this is how long right here? 10. Do you know what this is?
6.
If this is 6 and this is 10,
8.
this is an 8. There's our 6, 8, 10 triangle again. So now I know my slant height is 8. Okay, give me an answer for that. 192. Okay, and then I need to work on my surface area of my cube that it has only one base. Okay, so when I go to do the perimeter of the base, I do have to call this the base right here. So what would the perimeter of this base be? 48 again. And then how tall does this cube stand? It stands 12 tall. And then I only want the area of one base. So what's the area of this base? 144. 12 times 12, so 144. Okay, and then somebody work that out. 48 times 12 plus 144. 720. And what do you get when you add those two numbers together? 912. And this would be millimeters squared. And that's the total surface area of every surface that we could paint. But you can't paint the bottom of the pyramid, and you can't paint the top of the cube. Does that make sense? Do you feel like you kind of understand, or do you feel utterly confused? Feel like you understand? Okay, so I'm going to add this problem on. It doesn't say it right there, but I'm going to add this problem on. I want you to try example 5. This is on page 10. I don't have it on my board over there, but I want you to try example 5 on page 10, and then turn to page 11. And on page 11, I'm going to have you do, I can make this a little bit cleaner here, 3, 4, 5, and 6. So 3, 4, 5, and 6 on page 11, and then the example 5 on the previous page. So that's 5 total problems, and this is not due until Monday. So my hope is tomorrow you'll come in, you guys will take the quiz, and then you'll have time to work on this in class after you're done with your quiz. And of course you could work on it tonight if you wanted to work on it tonight, but this will not be due until Monday. So 3, 4, 5, and 6 on this page, and example 5 on the previous page. Yes, I do want you to do it on a separate piece of paper. Yeah, this is due Monday, and I do want you to do it on a separate piece of paper.